On a cold February morning in 1968, as the nuclear attack submarine USS Scorpion prepared to slip her moorings at Norfolk Naval Base, one man stood on the dock who felt nothing but relief. Electrician's mate Dan Rogers watched as the sleek black hull of the submarine disappeared into the gray waters of Hampton Roads, knowing he had narrowly escaped what he believed was certain death. Rogers had spent months aboard the Scorpion, witnessing firsthand the deteriorating condition of what the Navy proudly proclaimed as one of America's most advanced nuclear submarines. Oil leaked from hydraulic systems, seawater seeped through propeller shaft seals, and emergency ballast systems failed to function properly. The crew had taken to calling their vessel the USS Scrap-Iron, a dark joke that masked genuine fear about the submarine's seaworthiness. Just weeks before that February departure, Rogers had made an unprecedented decision that would ultimately save his life. In a letter to his commanding officer, he had formally requested a transfer, stating bluntly that everyone aboard the Scorpion was in danger. It was a career-threatening move that required courage few sailors possessed, but Rogers had seen enough. He knew that beneath the Navy's polished exterior lay a submarine that was pushing the boundaries of operational safety far beyond acceptable limits. It is still for 3 months later, on May 22, 1968, Rogers' fears would prove tragically prophetic when the USS Scorpion vanished beneath the Atlantic Ocean, taking 99 men to their eternal rest in the deepest grave imaginable. The loss of the Scorpion remains one of the most enduring mysteries of the Cold War, a puzzle that has generated countless theories, but no definitive answers. What makes this tragedy even more haunting is that it occurred during what naval historians now call the Year of Lost Submarines, when 4 nations lost submarines within months of each other, creating an atmosphere of suspicion and paranoia that gripped the underwater fleets of the world. To understand how America came to lose one of its most sophisticated nuclear submarines, we must first examine the revolutionary vessel that was the USS Scorpion. She was a skipjack-class nuclear attack submarine, representing the cutting edge of underwater warfare technology in the early 1960s. With her distinctive teardrop hull borrowed from the experimental USS Albacore, the Scorpion could achieve speeds of over 33 knots submerged, making her faster underwater than most surface vessels. The skipjack class marked a revolutionary departure from previous submarine designs. Where earlier submarines resembled surface ships that could dive, the skipjacks were true underwater vessels, optimized for submerged performance rather than surface operations. Their single propeller and streamlined hull allowed for unprecedented maneuverability, with the ability to turn in their own length and climb or dive like an aircraft. Built by General Dynamics Electric Boat in Groton, Connecticut, the Scorpion was laid down in August of 1958 and commissioned in July of 1960. She displaced over 3,500 tons when submerged and stretched 252 feet in length. Her S-5W nuclear reactor provided virtually unlimited endurance, constrained only by food supplies and crew fatigue. The submarine's armament consisted of 6 21-inch torpedo tubes loaded with the Navy's most advanced weapons, including the Mark 37 acoustic homing torpedo and the nuclear-tipped Mark 45 Astor anti-submarine torpedo. These weapons gave the Scorpion the ability to engage and destroy enemy submarines at ranges that would have been impossible for conventional torpedoes. Commander Francis Atwood Slattery assumed command of the Scorpion in October of 1967. Born in Maine in 1931, Slattery was a Naval Academy graduate who had dedicated his career to submarine warfare. At 36 years old, he represented the new generation of nuclear submarine commanders, men who had grown up with atomic power and understood its immense potential. Under Slattery's command, the Scorpion continued her role as one of the Atlantic Fleet's premier attack submarines, conducting training exercises and operational deployments that took her across the world's oceans. But beneath the surface of these routine operations lay a more sinister reality that few outside the submarine community understood. The early 1960s had seen the tragic loss of the USS Thresher, America's most advanced attack submarine at the time. The Thresher had imploded during deep-sea trials in April of 1963, killing all 129 men aboard. The disaster had shocked the submarine community and led to the creation of the Subsafe program, a comprehensive safety initiative designed to prevent similar catastrophes. Subsafe required extensive testing and certification of all submarine systems, critical to watertight integrity and emergency recovery. The program mandated rigorous quality control procedures, material traceability requirements, and comprehensive inspections that could extend submarine overhauls by months or even years. For a Navy struggling to maintain operational readiness during the height of the Cold War, These safety requirements created significant scheduling pressures. When the Scorpion entered Norfolk Naval Shipyard in February of 1967 for what should have been a comprehensive overhaul, the submarine was desperately in need of attention. Her hull showed signs of wear, her systems required extensive maintenance, and her crew had compiled over 100 unfulfilled work orders documenting various mechanical problems. However, operational demands during the Cold War were relentless. Intelligence missions required submarines to be at sea, not in shipyards, and the Navy faced pressure to keep its most capable vessels operational. The decision was made to conduct what officials termed an experimental accelerated overhaul procedure on the Scorpion, bypassing many of the safety checks and improvements that Subsafe required. The rushed overhaul relied on jury-rigged spare parts and quick fixes rather than comprehensive system replacements. Repair crews, working under intense time pressure, completed their work in just 7 months, rather than the typical 18 to 24 months required for a full Subsafe overhaul. The result was a submarine that returned to operational status without Subsafe certification, making her one of only 4 submarines in the Atlantic Fleet to lack this crucial safety designation. And the consequences of this decision became apparent almost immediately. The Scorpion's crew reported chronic problems with hydraulics, a malfunctioning emergency blow system, and leaking seawater shutoff valves. The submarine's diving depth was restricted to just 300 feet, less than half the normal operational depth for her class. Oil leaked from the conning tower as she departed Hampton Roads, leaving a visible slick on the water's surface. It was against this backdrop of mechanical problems and safety concerns that Dan Rogers made his fateful decision to request a transfer. Rogers had served aboard the Scorpion for over a year and had witnessed the gradual deterioration of the submarine's condition. He observed oil leaks in hydraulic systems, seawater seeping through propeller shaft seals, and emergency systems that simply did not work when tested. Perhaps most disturbing was an incident that had occurred 3 months before the Scorpion's final deployment. During high-speed underwater maneuvers, the submarine had begun to vibrate so violently that she seemed to corkscrew through the water, sending massive pieces of equipment swaying on their rubber mountings. The cause was never diagnosed, and the crew feared the problem could reoccur at any time, with potentially catastrophic results. Rogers' transfer request was approved, and he watched from the dock as his former shipmates departed for what would become their final voyage. Standing beside him were the families of the 99 men aboard, wives and children who had come to say goodbye, unaware that they would never see their loved ones again. The Scorpion's final deployment began as a routine NATO exercise in the Mediterranean Sea. The submarine departed Norfolk in February of 1968 and spent the next 3 months conducting training operations with Allied navies, serving as a target for anti-submarine warfare exercises that helped prepare NATO forces for potential conflicts with Soviet submarines. By all accounts, the Mediterranean deployment proceeded without major incident, though the submarine's mechanical problems persisted. Crew members wrote letters home describing continuing hydraulic leaks, equipment failures, and the general deterioration of their vessel's condition. Some described their submarine as being held together by little more than prayer and determination. On May 16, 1968, the Scorpion departed the Spanish naval base at Rota for her journey home to Norfolk. The crew was looking forward to returning to their families for Memorial Day weekend, but their homecoming would be delayed by a last-minute change in orders that would prove fateful. Admiral Arnold Shade, commander of the Atlantic Submarine Fleet, issued classified orders diverting the Scorpion toward the Canary Islands to observe unusual Soviet naval activity. A small flotilla consisting of an Echo II-class nuclear submarine, a submarine rescue vessel, and 2 hydrographic survey ships had been detected conducting what intelligence analysts described as hydroacoustic operations. These Soviet vessels were believed to be gathering intelligence on the American SOSUS underwater surveillance network, the secret system of seafloor hydrophones that allowed the United States to track submarine movements across the Atlantic Ocean. Any Soviet attempt to map or disrupt SOSUS represented a serious threat to American naval security, making surveillance of these operations a high priority. The Scorpion's mission was to observe the Soviet flotilla from a safe distance, gathering intelligence on their activities and capabilities. It was exactly the type of sensitive operation that required the stealth and endurance that only a nuclear submarine could provide. On the evening of May 21, 1968, Commander Slattery brought his submarine to periscope depth to transmit a routine position report. The message, relayed through a Navy communication station in Greece, indicated that the Scorpion was proceeding at 15 knots at a depth of 350 feet, closing on the Soviet formation to begin surveillance operations. Those would be the last words ever heard from the USS Scorpion and her crew of 99 men. When the submarine failed to arrive at Norfolk Naval Base on the morning of May 27th as scheduled, families gathered at the pier in growing anxiety. A spring storm lashed the Virginia coast with wind and rain, but the weather could not explain the submarine's absence. By evening, the Navy had officially declared the Scorpion overdue and launched what would become one of the largest search and rescue operations in maritime history. What the families did not know was that the Navy had already detected evidence of the Scorpion's fate. The SOSUS underwater surveillance network had recorded a series of acoustic events on May 22nd that suggested an underwater explosion, followed by the sounds of a submarine breaking apart as it exceeded its crush depth. These recordings, classified at the highest levels, indicated that the Scorpion had suffered a catastrophic failure while submerged. The search for the missing submarine involved dozens of ships and aircraft scouring the Atlantic Ocean over an area covering thousands of square miles. For days, hopes rose and fell as search crews investigated false contacts and unconfirmed radio signals. One transmission that included the submarine's codename Brandywine raised hopes briefly before being dismissed as either a hoax or interference from another source. On June 5, 1968, the Navy officially declared the Scorpion and her crew presumed lost, ending the immediate search and rescue phase of the operation. But the larger question of what had happened to America's most advanced attack submarine remained unanswered, and the Navy was determined to find the wreck and discover the truth. The task of locating the Scorpion fell to Dr. John Craven, chief scientist of the Navy's Deep Submergence Systems project, and a pioneer in the application of Bayesian search theory to underwater recovery operations. Craven had previously used mathematical probability methods to locate a lost hydrogen bomb in the Mediterranean Sea, and his techniques represented the most advanced search methods available at the time. Craven's approach involved creating detailed probability maps based on multiple theories about what might have happened to the submarine. He assembled teams of experts who generated 9 different scenarios for the Scorpion's loss, ranging from mechanical failure to enemy action, and assigned probability values to each possibility. The acoustic data from SOSUS provided crucial clues about the submarine's final moments. Analysis of the recorded sounds suggested that the Scorpion had been traveling eastward, away from her planned course to Norfolk, when the catastrophic event occurred. This unexpected direction change would later support theories that the submarine had attempted an emergency maneuver in response to some onboard crisis. Using sophisticated computer models and careful analysis of ocean currents, water depth, and the submarine's probable speed and heading, Craven's team created a detailed search grid covering hundreds of square miles of ocean floor. The most likely location for the wreck was identified as an area approximately 400 miles southwest of the Azores Islands, where the ocean depth exceeded 11,000 feet. The search vessel chosen for this daunting task was the USS Mizar, a civilian-operated oceanographic research ship equipped with sophisticated underwater cameras and magnetic detection equipment. The Mizar had previously located the wreck of the USS Thresher and possessed the specialized capabilities needed to search in the deep Atlantic Ocean. On October 28, 1968, after months of methodical searching guided by Craven's probability calculations, the Mizar's cameras finally captured images of twisted metal and debris scattered across the ocean floor. The distinctive teardrop shape of a skipjack-class submarine was unmistakable, even crushed and broken by the immense pressure of the deep ocean. The wreck of the USS Scorpion lay in pieces, her hull split into several sections by the devastating effects of implosion and impact with the seafloor. The submarine's sail had been torn away, and her operations compartment had collapsed inward under pressure that exceeded 1,700 pounds per square inch. Despite the destruction, enough of the submarine remained intact to provide clues about her final moments. The discovery of the Scorpion's wreck marked the beginning of a new phase in the investigation, as Navy experts analyzed thousands of photographs and gathered physical evidence from the debris field. What they found would generate multiple theories about the submarine's loss, each supported by different aspects of the available evidence. One of the most widely accepted theories centers on a malfunctioning Mark 37 torpedo. These acoustic homing torpedoes were known to suffer from hot run incidents, where the weapon would accidentally activate while still in its tube. The torpedo's silver-zinc battery was prone to overheating, and if the weapon became fully armed and was ejected from the submarine, it could potentially target the very vessel that launched it. Supporting this theory is evidence that the Scorpion was heading eastward when she was destroyed, suggesting that Commander Slattery had ordered a 180-degree emergency turn. Such a maneuver was standard procedure for dealing with a hot-running torpedo, as it would activate the weapon's anti-friendly fire mechanism and prevent it from targeting the launching submarine. Another theory focuses on the submarine's problematic trash disposal unit. The Scorpion had been awaiting a replacement latch for this system, and similar units had caused flooding problems on other submarines. If the trash disposal unit malfunctioned and allowed seawater to enter the submarine, it could have reached the massive 69-ton battery bank and caused a catastrophic explosion. The battery explosion theory is supported by debris recovered from the wreck site, including battery covers that showed evidence of violent internal explosions. Metal fragments were embedded in the covers with such force that could only have been driven by high-velocity explosions in air, not water, suggesting that the battery compartment was dry when the explosion occurred. A third possibility involves hydrogen gas buildup during battery charging operations. Nuclear submarines still required battery power for emergency operations, and the charging process produced hydrogen gas as a byproduct. If proper ventilation procedures were not followed, or if the submarine's ventilation systems malfunctioned, hydrogen could accumulate to explosive levels. A single spark could then trigger an explosion powerful enough to rupture the submarine's hull. The hydrogen explosion theory correlates with acoustic evidence from the SOSUS recordings, which captured two distinct explosions, approximately half a second apart. This timing matches the pattern that would be expected if a hydrogen explosion triggered a secondary blast involving the submarine's battery or torpedo warheads. And perhaps the most controversial theory suggests that the Scorpion fell victim to enemy action, potentially a Soviet attack in retaliation for some perceived American aggression. Proponents of this theory point to the unusual number of submarine losses in 1968, when 4 nations lost submarines within months of each other. The Soviet submarine K-129 had disappeared in the Pacific in March. The French submarine Minerve was lost in the Mediterranean in January, and the Israeli submarine Dakar vanished in the same waters where the Scorpion was operating. However, there is no credible evidence to support the enemy action theory, and the small Soviet flotilla that the Scorpion was observing lacked the firepower to seriously threaten an American nuclear submarine. The timing of multiple submarine losses in 1968 appears to be coincidental rather than evidence of underwater warfare. The official Navy investigation, conducted by a court of inquiry that examined all available evidence, was unable to determine the exact cause of the Scorpion's loss. The court's final report, issued in January of 1969, concluded that the certain cause of the loss could not be ascertained from the evidence available. This inconclusive finding has fueled decades of speculation and conspiracy theories about what really happened to America's most advanced attack submarine. What is certain is that the loss of the USS Scorpion marked a turning point in submarine safety procedures. Never again would the Navy rush an overhaul at the expense of safety requirements, and the Subsafe program became an absolute requirement for all operational submarines. The Mark 37 torpedo was redesigned to eliminate the problems that may have contributed to the Scorpion's loss, and new procedures were implemented to prevent hydrogen gas accumulation during battery charging operations. The wreck of the USS Scorpion remains on the ocean floor today, a monument to the 99 men who gave their lives in service to their country. The submarine's nuclear reactor and nuclear-tipped torpedoes continue to be monitored by the Navy, which conducts regular inspections to ensure that no radioactive materials have been released into the marine environment. The mystery of what exactly happened during the Scorpion's final moments may never be fully solved. The crushing depths of the Atlantic Ocean have preserved the submarine's remains, but they have also made detailed forensic investigation nearly impossible. What we do know is that the loss of this remarkable vessel and her crew represents one of the most tragic incidents in American naval history, a reminder of the incredible risks faced by the men who operate in the silent depths beneath the waves. The legacy of the USS Scorpion extends far beyond the circumstances of her loss. The lessons learned from this tragedy have made submarine operations safer for generations of sailors who followed, ensuring that the sacrifice of her crew was not in vain. In the dangerous game of Cold War submarine warfare, where the margin for error was measured in seconds and the stakes were measured in lives, the Scorpion and her crew paid the ultimate price for America's security. Beneath the waves. Today, as nuclear submarines continue to patrol the world's oceans in defense of freedom, the memory of the USS Scorpion serves as both inspiration and warning. Her story reminds us that even the most advanced technology is only as reliable as the human beings who operate and maintain it, and that the price of freedom is sometimes paid in the darkest depths of the sea, where no memorial can mark the final resting place of those who gave everything in service to their nation.